This is a video walkthrough for practice 8D. In the first question, we're asked how we know that this graph does not represent a cubic function or a degree 3 function, even though there are exactly 3 real zeros. So we can see those right there. 3 x-intercepts, those are synonymous with real zeros. So there are 2 reasons that I can think of. So because this graph points upward on the right and the left sides, the polynomial must be of even degree. Also, x equals 3 is a double zero because of the way the graph bounces off of the x-axis at that zero. So that counts twice. Therefore, this polynomial must be at least 4th degree. In 2 through 4, we're directed to use the leading term to determine the end behavior of each graph. Leading term in number 2 is 3x to the 4th. That's the term with the highest exponent on x. And since a is positive, which is 3, our right end must point up, and our left end is determined by the degree of the function. It's an even degree, so left end will do the same thing as the right end. In number 3, our leading term is 2x to the 5th. Because a is a positive number, 2, our right end will go up. Since the degree 5 is an odd number, the left end will do the opposite or go downward. In number 4, our leading term is actually negative 3x to the 5th, the term with the highest exponent on x. Since the leading coefficient is negative, our right end will be pointing downward. And since the degree is odd, the left end will do the opposite or point upward. In 5 through 8, we're asked to find the leading term when written in standard form. And our leading term is the leading coefficient, negative 1, times the first term in each of the factors, so negative x times x times x times x, or negative x to the 4th. And we can write a 1 there if we want. Negative 1 is the leading coefficient. The degree, therefore, is degree 4. And since the lead coefficient is negative, the right end behavior is down, and the left end behavior, because we have an even degree, is the same direction, also down. In number 6, our lead coefficient is 1, so the lead coefficient times the first term in each of the factors is 1x cubed. The degree, therefore, is 3, and because the lead coefficient is positive, the right end will head upward. Since the degree is odd, the left end does the opposite. In number 7, the leading term is the lead coefficient, negative 1, times the first term in each factor, but x plus 2 is a factor twice, so we have an x squared there, times an extra x in the third factor. So negative 1 times x cubed is the leading term. The degree, therefore, is 3. And the right end behavior will be down, since we have a lead coefficient that's negative. Since the degree is odd, the left end will do the opposite or head upward. In number 8, our leading term is the product of all of those leading terms. And so x times x squared times x cubed is x raised to the 6th power, or 1x to the 6th power. The degree, therefore, is 6. Since the lead coefficient is positive, the right end will head upward, and since the degree is even, the left end does the same. In number 9, our lead term is x times x times x times x, or x to the 4th power, or 1x to the 4th power. That's degree 4. Because the lead coefficient is positive, right end is up. And because we have even degree, left end is also up. Our zeros are the zeros of each factor. The 0 of the first factor is x equals 0, and that's a multiplicity 1 since the factor only occurs once. The 0 of the second factor is x equals 2, that's also multiplicity 1. When x minus 5 is equal to 0, x is 5, that's also multiplicity 1. And when x plus 4 is equal to 0, then x is equal to negative 4, and that's also multiplicity 1. So I'm going to plot all those zeros at x equals 0, at x equals 2, and x equals 5, and also x equals negative 4. Since they're all multiplicity 1, the graph will pass through the x-axis kind of in a straight line, although generally speaking this is a curve. And our right end behavior is upward. So the graph will pass below, then come back up, and then go back down, and then come back up, and then the left end behavior is also up. In number 10, the leading term is x times x times x, which is x to the third power, or 1x to the third power, and the degree is 3. And so because our leading coefficient is a positive number 1, the right end behavior is up. Because it's odd degree, the left end behavior is opposite or down. Each of these zeros is multiplicity 1 because none of these factors are repeated. When x minus 3 is equal to 0, x is 3. When x plus 1 is equal to 0, x is negative 1. And when x minus 6 is equal to 0, x is 6. All multiplicity 1 because each factor is raised to the first power. So x equals 3, x equals negative 1, and x equals 6 are our zeros or x-intercepts. And our right end is up, and the graph just passes through, and the left end is down. In number 11, our lead coefficient negative 1 times the first term in each of the factors, negative x times x squared, is negative x to the fourth power. That's a fourth degree. Since our lead coefficient is negative, the right end behavior is down. And because we have an even degree, the left end is the same, also down. In this case, our first factor, x, is equal to 0 when x is 0. This factor only occurs once, so the multiplicity is 1. Our second factor, x plus 3, is equal to 0 when x is negative 3. This factor also occurs only once. And then the third factor, x minus 2, is equal to 0 when x is 2. But this factor occurs twice since x minus 2 is squared. Let's plot these zeros. X equals 0, x equals negative 3, and x equals 2. And our right end behavior is downward. At x equals 2, however, the graph is bouncing off of the x-axis, so we're going to draw a bounce there, and the right end behavior right of x equals 2 is downward. So it bounces and then comes back up, passes through, and then passes back downward. In number 12, x times x cubed times x is x raised to the fifth power, or 1x to the fifth power. That's degree 5. Since the lead coefficient 1 is a positive number, then the right end behavior is up. And since we have an odd degree, the left end behavior is opposite or down. In the function, our first factor, x plus 2, is equal to 0 when x is negative 2. That factor is raised to the first power, so multiplicity is 1. Second factor, x minus 1, is equal to 0 when x is 1. That factor is raised to the third power, so our multiplicity is 3. And the third factor, x minus 5, is equal to 0 when x is 5, and that factor is multiplicity 1. Let's plot the zeros. X equals negative 2, x equals 1, and x equals 5. Our right end behavior is up. The graph passes through because we have a multiplicity 1 at x equals 5. At x equals 1, the graph is going to pass through, but it's going to flatten as it passes through. This may be a challenge to draw at first. Just make sure that you exaggerate that. And then the graph comes back down to the next 0 and passes straight through, so that our right end is up and our left end is down. I'm going to fix that. And number 13, our leading term is -1 times x squared times x squared, or -1x to the 4th. That's degree 4. Right end behavior is down because the lead coefficient -1 is a negative number, and because it's degree 4, an even degree, the left end does the same as the right end, so also down. If we look at the function, our first factor, x minus 1, is equal to 0 when x is 1, and that's multiplicity 2 because the factor is raised to the second power. Our second factor, x plus 4, is equal to 0 when x is -4, and that's also multiplicity 2 because that factor is also raised to the second power. Plotting those x-intercepts, 1 and -4, our right end behavior is downward, but the graph in each case for each of these zeros is bouncing off of the x-axis. So downward here, and then bouncing off of the x-axis and downward on the left end as well. In 14, the lead term is x squared times x cubed, so that would be x raised to the 6th power, and since the lead coefficient is positive, that means our right end behavior is up, and that's degree 6, which is an even degree, and so that means that the left end behavior is the same direction or also up. Let's take a look at each of the factors. The first factor, x plus 3, is equal to 0 and x is -3. That's multiplicity 2 because the factor is raised to the second power. X plus 1 is equal to 0 when x is -1. That's multiplicity 1 because that factor is raised to the first power. X minus 4 is equal to 0 when x is 4, and that's multiplicity 3 because it's raised to the third power. So now let's graph each of those intercepts or zeros at -3, -1, and 4. And our right end behavior is up, but at x equals 4, the graph should be looking like a cubic function because we have a multiplicity 3 there, so it's going to flatten but pass through, coming back up to x equals -1, which is multiplicity 1, so the graph kind of passes straight through, and then comes back down to x equals -3, but the graph is bouncing there off of the x-axis because that 0 is multiplicity 2. In 15, the leading term is -1 times x squared times x cubed times x, so that would be -1x to the 6th power. That's a 6th degree polynomial, and since the lead term has a negative coefficient, then that means the right end is downward, and because this is an even degree, the left end will do the same thing, so also down. Let's take a look at each of the factors. X plus 2 is equal to 0 when x is -2, and that's of multiplicity 2 because the factor is raised to the second power. Next factor, x minus 1 is equal to 0 when x is 1, and that's multiplicity 3 because that factor is raised to the third power. X plus 4 is equal to 0 when x is -4, and that's multiplicity 1 since the factor is raised to the first power. Let's graph the zeros, -2, +1, and also -4. Our right end behavior is downward, and at x equals 1, we have a multiplicity 3, so that's going to look like a cubic function as it passes through. Graph is flattening out. And then at x equals -2, we have a multiplicity 2. The graph's going to bounce at that point, bounce off the x-axis, so it's going to go downward toward it and then back up and then back through at -4. That's a kind of straight through since that's a multiplicity 1 factor. In 16 through 19, we're asked to write the equation for the polynomial function in factored form. Be sure to considering those zeros and their multiplicities, and use the additional point given to determine the value of the lead coefficient. So, I see 2 zeros here. I see -3, which is a multiplicity 2, because the graph bounces off the x-axis, and I see x equals 1, which is a multiplicity 1, because the graph is kind of passing straight through. So that means that we have an equation in the form y equals a times x plus 3 squared. That's because we have an x equals -3, 0, and it's of multiplicity 2. And then the second factor here is x minus 1, and that's multiplicity 1, so it's raised to the first power, so we don't need to write an exponent there. Now I'm going to use the extra point. Our extra point is a point that has coordinates -1, 3. So that means 3 is the value of y whenever x is -1. So 3 is equal to a times -1 plus 3 squared times -1 minus 1. So 3 is equal to a times 2 squared, which is 4, times -1 minus 1, which is -2. So 3 is equal to -8 times a, or a is -3/8. Now rewriting the equation, y is equal to -3/8 times x plus 3 squared times x minus 1. In number 17, there are two zeros, one at x equals -1, which is a multiplicity 3, since the graph flattens out near there. And then we have x equals 2, and that's a multiplicity 2, since the graph bounces off the x-axis. So the equation must be y is equal to a, the leading coefficient, times x plus 1 raised to the third power, times x minus 2 raised to the second power. Now we're going to use that extra point, which has coordinates of 1, 5. So that means that y is 5 whenever x is 1. So 5 is equal to a times 1 plus 1 cubed times 1 minus 2 squared. So 5 is equal to a times 2 cubed, which is 8, times -1 squared, which is +1. So 5 is equal to 8 times a. That means that a is 5/8. So the equation must be y is equal to 5/8 times x plus 1 cubed times x minus 2 squared. In 18, I'm going to list the zeros here one by one as I'm writing the equation. So y is equal to our lead coefficient a times x plus 4 would be x minus that 0, and that's going to be raised to the first power since the graph passes straight through. And then we have another factor here, x, or x minus 0. That's also raised to the first power since the graph passes straight through. And then we have another factor of x minus 2. That's also raised to the first power, and x minus 5. So all of these are multiplicity 1 zeros. And typically, that's going to be rearranged so that that monomial factor of x is the first one. The order doesn't really matter, but it is traditional to write that monomial factor first. So now let's use that extra point to find the value of a. The extra point has coordinates of 3, 1, so that means that y is 1 whenever the x value is equal to 3. So 1 is equal to a times 3 plus 4 times 3 minus 2 times 3 minus 5. Or 1 is equal to a times 3 times 7 times 1 times -2. Or 1 is equal to -42 times a. And that's going to give us an a value of -1/42, which means the equation is y is equal to -1/42 times x plus 4 times x minus 2 times x minus 5. In 19, we have 1, 0. X equals -3, so that gives us a factor of x plus 3. And that's going to be squared since the graph bounces off of the x-axis. Our next factor is x plus 1, since we have a 0, x equals -1. That one passes straight through, so that'll be raised to the first power. And then we have x equals 2. That gives us a factor of x minus 2. That'll be cubed since the graph flattens out as it passes through the x-axis there. Now let's use the extra point to find the value of a. The extra point has coordinates 0, negative 3, so that means that y is negative 3 whenever x is equal to 0. So negative 3 is equal to a times 0 plus 3 squared times 0 plus 1 times 0 minus 2 cubed. So negative 3 is equal to a times 9 times 1, and then negative 2 cubed is negative 8. So negative 3 is equal to negative 72 times a, and dividing a is 1/24. So that gives us an equation: y is equal to 1/24 times x plus 3 squared times x plus 1 times x minus 2 cubed.